Hi guys, welcome to a new video on differentiation, paper 2 questions under math studies. This video deals with level 3 questions, intermediate level questions, and I shall deal with the two questions on the screen in front of you, and I shall begin the first question shortly. We shall now attempt to solve paper 2 May 2009 time zone 1 question 5. Kindly take a minute and attempt to solve. The answer shall follow through shortly. So you are given the function f of x equals 3x plus 12 over x squared, and you are asked to differentiate f of x with respect to x. So I have rewritten the function there. F of x equals 3x plus 12x to the power of negative 2. I've taken x squared from the denominator and rewritten it using a negative exponent in order to help me with the differentiation. So f dash of x shall be 3, the derivative of 3x is 3, and the derivative of 12x to the negative 2 shall be negative 24x to the negative 3. I reduce the power by 1. I've also rewritten the derivative in terms of a positive exponent for x cubed. So I've taken it to the denominator. Instead of 24x to the power of negative 3, I have 24 over x to the power of 3. And they mean the same thing. I like to write every function in both forms because you never know which form shall be more useful in the consequent questions. In B, I'm required to calculate f dash of x when x equals 1. So I simply substitute 1 for x in the equation of f dash. So instead of this x right there, I have put a 1. Hence 3 minus 24 over 1 cubed is negative 21. In C, I am asked to decide whether the function is increasing or decreasing when x equals 1. This depends on the sign of the slope, and since we know from B that the slope is negative, hence the function is decreasing. Since this value is negative, hence the function is decreasing because the slope is negative. Next, in question D, I need to solve the equation f dash of x equals 0. So I simply solve the equation in blue right there, equaling it to 0. You can either do this using algebra or using the GDC. I shall show you right now how to use the GDC to solve this. So I've written my equation down on the GDC. Here is the window for your reference, and I've clicked on trace. There is my function. I want to solve this function equal to 0, so the y value is 0, so I want to find the x-intercept or the value of x at this point. So in order to find the value of x at this point, I shall click on second, trace 0, and I shall drag the cursor to the left of my x-intercept and then to the right of my x-intercept and then a guess, and the calculator tells me that there is a 0 when x equals 2, matching the answer right there. In question E, I'm told that the graph has a local minimum at point P. Let T be the tangent to the graph of f at P. Write down the coordinates of P. So we know that a local minimum is a point where f dash of x equals 0. So I shall build on question D. The answer to question D shall be the x coordinate of my point P, because this is the value of x that makes f dash of x equal to 0. and a minimum point is a point where f dash of x equals 0. So that's the same thing. So minimum point, hence f dash of x equals 0, and from the last question I know that this corresponds to x equals 2, so this is my x coordinate. In order to get the y, I simply plug x equals 2 into the original function, and this gives me 3 times 2 plus 12 over 2 squared, which is 9. Hence my minimum point exists at point 2, 9. Next, I need to find the gradient of the tangent and the equation of the tangent. So the gradient of the tangent is obviously 0 because we already know that f dash of x equals 0. And the equation of the tangent requires a point and the slope, and we already know that the tangent exists at point 2, 9, and that the slope is 0, so we substitute into the point slope formula y minus 9 equals 0 times x minus 2, hence y minus 9 equals 0, and hence y equals 9. Next, in f, I need to sketch the graph of the function for this domain and this range, and I need to indicate the point P and any intercepts of the curve with the axes. So let's check this out. So I've written down the original function 3x plus 12 over x squared. I've set my window to match the instructions given in the question for x and y, negative 3 to 6 for x and negative 7 to 15 for y. And I've clicked on trace to see what the function looks like. This is the sketch that I should have, and I should indicate clearly the point P, which is the minimum point, which shall be right there, as well as the value of the intercept, or where the curve intersects the x-axis. I can find the coordinate of this point by pressing on second, trace, 0, left bound, right bound, guess, and the calculator tells me that the 0 exists at negative 1.587 or just negative 1.59. So we can see that the marking scheme version looks very similar to what we have on our GDC. You are awarded 1 mark for labels of the axes and some indication of scale. Another mark for the correct general shape, which is copied from the GDC. A mark for the x-intercept seen in roughly the correct position, which is negative 1.58, so between negative 1 and negative 2. And a final mark for the minimum value at P, so P has to be at the minimum point of the curve. Finally, in question G, I am required to draw and label the tangent T, which is the tangent at P from E. We know that T is the tangent to the graph of f at point P, so I need to draw and label this tangent. And I need to write down the x-coordinate of the point of intersection between the graph of f and t. So let's take a look. So the equation of the tangent is y equals 9. I can use the GDC to plot this tangent. So there is my second equation. And here is my tangent. I already know that it is a tangent at this point. However, I am now required to find the intersection between the tangent and the curve right there. So I press on second, trace, intersect, first curve, second curve, and the guess. and the calculator tells me that the intersection is at -1 and 9. So x equals -1. Or you can do this manually as I've done right there. This shall also work. So take a minute to write the answer down if you will. I hope you have found this useful. I shall now attempt to solve November 2012 question 5. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So you are given this function g of x equals bx minus 3o plus 1 over x squared, and in A you are required to write down the equation of the vertical asymptote. So we should know that the vertical asymptote exists wherever there is a denominator equal to 0. Hence, in this function, the vertical asymptote shall exist when x squared equals 0, hence when x equals 0. So the equation of the vertical asymptote is x equals 0. In B, I want to write down g dash of x, so let's take a look at how to do that. So I begin by writing the original function in a different form. So this is what I've done here in red. This is the same function as the original function given in the question. However, I took the x squared from the denominator to the numerator, and it became x to the power of -2. Next, I do the differentiation, which shall be easier now. Bx becomes b, the 3 vanishes, and x power -2 becomes -2 x power -3. Next, you are told that the line t is the tangent to the graph of y equals g of x at the point where x equals 1. The gradient of t is 3. Show that b equals 5. So the gradient is 3 at the point where x equals 1, because we know that the gradient of the tangent at a point is the gradient of the curve at this point. So the gradient of the tangent at x equals 1 is 3. Hence, f dash equals 3 when x equals 1. Or, excuse me, g dash equals 3 when x equals 1. Hence, g dash of 1 equals 3. I substitute 1 into my g dash, and this gives me b minus 2 times 1 to the power of -3. So b minus 2 equals 3 and b equals 5. Next, I'm asked to find the equation of the tangent, and since the tangent is a line, then in order to get the equation I need a point and the slope. The slope, or the gradient, is given to be 3 in the question. So all I need now is a point on this line. And usually this is the point where the tangent intersects the graph. So we know that the tangent intersects the graph at the point where x equals 1. So what remains for me to do is to find the corresponding y value for x equals 1. And this is found by plugging 1 into the original function, noting that I now have the value of b with me, which is 5. So I need to get the y value when x equals 1. This corresponds to g of 1, and I've plugged the 1 here, as we have explained, into the original function. So I get b minus 3 plus 1, and we know that b is 5, so 5 minus 3 plus 1, which gives me 3. Hence, when x equals 1, the corresponding value of y is 3. So I have a point, I have a slope. Next, I find the equation by plugging into the point-slope formula, and there it is. Y minus 3 equals 3 times x minus 1. In E, I'm told using your GDC, find the coordinates of the point where the graph y equals g of x intersects the x-axis. So I want the x-intercepts of this function. So what I need to do is first to sketch the function on the GDC and then find the x-intercepts, or what we call the zeros of the function. This is what the GDC calls the x-intercepts. So there is my equation written on the GDC, similar to the equation given in the question, but now we know the value of b. Next I click on trace. There is my function. So second trace 0. I know that the point where the curve crosses the x-axis is roughly somewhere here. So my left bound shall be somewhere here, my right bound there, and my guess right there. So the calculator tells me that the x-intercept exists at negative 0.439, which is this number. Hence, this is my point where the curve crosses the x-axis. Next, you are required to sketch the graph of y equals g of x for the given windows, indicating clearly the answer to part E, which is where the graph cuts the x-axis. So I shall go to window to adjust my values. So negative 2 less than x less than 5, and negative 15 less than y less than 25. These are the windows given in the question. Then I click on trace again, and there is my function, and I need to stick to this window in my sketch, and I need to show on my sketch the point where the curve cuts the x-axis. Having already found the coordinates in the previous question, I can add them to my sketch in small handwriting right there, just a bracket with the value of x and the value of y. Next, you are required to draw the line T on your sketch. So let's take a look. There is the marking scheme version of the graph, and we have to draw a tangent line to the point where x equals 1. So let's quickly scan what they require in their instructions for the marking scheme. You get one mark for labels and scale of the axes, so x and y and the corresponding numbers. One mark for the correct general shape and a smooth curve that does not cross the y-axis, because there is an asymptote when x equals 0. The y-axis is an asymptote, so the curve cannot cross the y-axis. You get one mark for the x-intercept, and it has to be consistent with your answer to part E. So negative 0.439, which is roughly between 0 and negative 1, almost negative 0.5. So there is the point, and it would help if you write these coordinates next to your graph so that they know that you understand what's going on. And finally, a mark for the local minimum in the first quadrant, so upper right corner of the graph. You have to have a minimum point in this region. You cannot have the minimum in this region, for example. The minimum has to exist in positive x and positive y. You also get a mark for the tangent curve approximately at x equals 1, and another mark for the line passing through the origin. So if we plot the tangent line, if we use the equation of the tangent line, which I obtained from the equation we got in D, I can just write that on the GDC as follows: y equals 3x, and if you trace, you shall find the tangent drawn as you should draw it in your sketch, and you shall note that the tangent line does indeed pass through the origin. So it is always useful to draw the tangent line on your GDC to see how it should look like. Next, in G, I am told, using your GDC, find the coordinates of the local minimum point. So let's check this out. So second, trace minimum, and you drag the cursor to the left of your minimum point and then to the right, and then a guess, and your answer is 0.737 and 2.53. These are your coordinates. There they are. Finally, in H, you are required to write down the interval for which g of x is increasing in the domain 0 less than x less than 5. So let's take a look. The domain exists from 0 to 5, which is the end of my graph. So I don't care about the part to the left of the y-axis. I only care about the part to the right of the y-axis. So where is the curve increasing here? The curve is increasing starting the minimum point. To the right of this point, the curve is increasing. To the left of this point, the curve is decreasing. So I just care about the part that exists to the right of my minimum point. Hence, x is greater than this value and less than 5, which is the end of my domain. And there is your answer to H. So this concludes our question. Take a minute to write the answers down if you will. I hope you have found this useful.